Welcome students. As we had already read about the chapter number 6, which is magnets of your physics book, we had read about the magnets, how magnets were discovered, magnetic and non-magnetic materials. We have already read in the previous session. Now today we will take about the magnetic fields. So let's start it, students. So here you can see this is the magnetic field. So just as an electric charge creates an electric field, in the same way a magnet creates a magnetic field. As we have already studied in the previous chapter, that then moving charge creates an electric field. Okay, in the same way a magnet creates a magnetic field around it. The space surrounding a magnet in which magnetic force is exerted is called a magnetic field. So the space means when you put a magnet on a table and bring a needle, or you can say a pin, iron pin, close to the magnet, then it attracts toward the magnet because magnet creates a magnetic field around it. So the space surrounding a magnet in which a magnetic field force is exerted is known as magnetic field. Similarly, a compass needle placed near a magnet gets deflected due to the magnetic force exerted by the magnet, and the iron filings also cling to the magnet due to the magnetic force. These are also the examples of magnetic force. The magnetic field pattern formed due to the bar magnet is shown in the figure 6.9. Here you can see this is the figure 6.9. We place a bar magnet which has two poles, north and south, and the lines you can see here in the figure are moving from the north pole to the south pole, and some lines are moving from north pole outward and some lines are coming to the south pole. So the magnetic field has both magnitude and as well as direction. A magnetic field is described by drawing the magnetic lines, as you can see in the figure above. We will now describe how the magnetic field lines produced by a bar magnet can be plotted on a paper. So here we will study how we can design or produce magnetic line on a bar magnet. You can see here the figure number 6.10. As you can see, this is the figure number 6.10. Here you can see that to understand the magnetic line of force, place a card, thick stiff paper over a strong bar magnet. Fine. Sprinkle a thin layer of iron fillings over the card. Just take a card, or you can take a paper and put some iron fillings, fine, over the paper, and that paper you what to do with the help of a sprinkler, and then tap the card gently. The iron fillings arrange themselves in a regular pattern and put that paper or card on the bar magnet. You will see that the iron fillings arrange themselves in a regular pattern. This arrangement of iron filling gives us a rough picture of the pattern of magnetic field produced by a bar magnet. This happens as follows. So how it will takes place? The bar magnet exerts a magnetic field all around it. What happens when you put a paper or a cardboard in which you put some iron fillings or any magnetic material over the paper or cardboard? Then the bar magnet exerts a magnetic field all around it. The iron fillings experience the force of magnetic field of the bar magnet. The magnetic material, or you can say iron fillings you put on the paper, experience a force of magnetic field on the bar magnet. The magnetic field of the bar magnet, the force of magnetic field of the bar magnets make the iron fillings to arrange themselves in a particular pattern. Actually, under the influence of the magnetic field of the bar magnet, the iron fillings behave like a tiny magnet and align themselves along the direction of the magnetic field lines. So when you put some iron fillings on a paper, the iron fillings arrange themselves in a particular pattern. Actually, under the influence of magnetic field means the magnetic field created by the magnet of the bar magnet, the iron fillings behave like a tiny magnet. The iron fillings behave like a tiny magnet for that magnet. The iron fillings behave like a tiny magnet and align themselves along the direction of the magnetic lines. Thus, iron fillings show the shape of magnetic field. So, the shape of the magnetic field you can see through this picture. The iron filings show the shape of the magnetic field produced by the bar magnet by aligning themselves with the magnetic field lines. Fine? Okay. Now we will move to what are the properties of the magnetic field lines. Here you can see that the magnetic field lines originate from the north pole of the magnet and end at its south pole. So first property says that the magnetic line of forces always originate from the north pole of the magnet, as we have already studied that the magnet has two poles and they always exist in pair. So a magnet has a north pole as well as south pole. So what is the written here? The magnetic line of originate from the north pole of a magnet and end at its south pole. Fine. Okay, the next point is the magnetic line come closer to one another. Here you can see is point number 2. The magnetic line come closer to one another near the pole of a magnet, but they are widely separated at other places. What does it mean? Where the intensity, as I already told you, the intensity or you can say strength of the magnetic field is very high at the poles. So the magnetic field lines come closer to one another near the poles. That's why the magnetic field lines come closer to the poles of a magnet, but they are widely separated at other places. But at other points of the magnet, they are very far away. From this, we concluded that where the magnetic field lines are closer together, it indicates a stronger magnetic field, as we had already studied. On the other hand, when the magnetic field lines are widely separated, then it indicates a weak magnetic field. So where the lines are very far away, then you can say that the magnetic fields are very weak. Fine. Now we will come to point number 3. Here you can see the magnetic field lines do not intersect or cross one another. This is due to the fact that the resultant force on a north pole at any point can only be in one direction. This is the most important point, that the magnetic field lines do not cross or intersect one another. As you can see in the figure number 6.9, I told you here the magnetic field lines originate from the north pole and some are moving outward and some are coming inward. So that is the thing written here, that the magnetic field lines do not intersect or cross one another due to the fact that the resultant force on a north pole at any point can only in one direction. I hope it is clear for you. Now we will come to magnetic field on Earth. Here you can see that a freely suspended magnet always point in the north-south direction even in the absence of any other magnet. These are the things we had already covered in the starting of the chapter. Same thing it is written here, that if a magnet is hang through a thread then it always rests in the north-south direction in the absence of any other magnet. This suggests that the earth itself behaves as a magnet, which causes a freely suspended magnet or a magnetic needle to point always in a particular direction, that is your north and south direction. Clear? The shape of the earth's magnetic field resembles that of an imaginary bar magnet, which is 1/5 of the earth diameter in length, buried at its center. Here you can see this is the earth magnetic field in the figure 6.12 here. Clear? The south pole of the earth magnet is in the geographical north because it attracts the north pole of the suspended magnet. The south pole of a earth magnet means the south pole of the earth geographical north because it attracts the north pole of the suspended magnet. It is actually a geographical north. Why? Because it attracts the north pole of the suspended magnet. Similarly, the north pole of the earth magnet is the geographical south. North pole of the earth is actually a geographical south. That's why it attracts the south pole of the suspended magnet. Thus, there is a magnetic south pole near the geographical north and a magnetic north pole near the geographical south. The position of the earth magnetic poles are not well defined. Here you can see it is written here. They are spread over an area. The axis of the earth magnet and the geographical axis do not coincide with each other. The axis of earth magnetic field is inclined at an angle about 15 degree with the geographical axis. So this is the thing that you have to remember. The axis of the earth magnetic field is inclined at an angle of how much? 15 degree. with the geographical axis. Due to this, a freely suspended magnet or a needle make an angle of about 15 degree with the geographical axis and point only approximately in the north-south direction at a place. In other words, you can say that a freely suspended magnet does not show exact geographical and south because the magnetic axis and the geographical axis of the earth do not coincide. They do not coincide, that's why we are not able do not show a geographical and south north because the magnetic axis and the geographical axis of the earth do not coincide. It is now believed that the earth magnetism is due to the magnetic effect of current. Now it is believed that the magnetism in the earth, it is due to the magnetic effect of current which is flowing in the liquid core of the center of the earth. Thus the earth can be said to be a huge electromagnet. So here you can say that the earth is all itself as a huge electromagnet. I hope it is clear. Now we will move to making of magnet. How we make magnet? Here you can study about the making of magnet. So there are many ways of making magnets. These are induction method, stroking method and electrical method. Let us learn these methods one by one in detail. So first we take the induction method. Here it is written as induction method. What happened in this method? In this method, a magnetic material I hope you know very well, that is which attract toward the magnet like iron, steel, etc. So in this method, a magnetic material like soft iron bar is kept very close to a permanent magnet without touching. What does it mean? You put a bar magnet, any permanent magnet, and from other side you put any magnetic material and move that magnetic material toward the permanent magnet without touching it. The soft iron bar become an induced magnet with the end nearer to the magnet. So the end point of that material which is close to the permanent magnet, a property of magnetism is self-induced on that material. On that material, or you can say on that end which is very close to the permanent magnet. The soft iron bar become an induced magnet with the end nearer to the magnet, having opposite polarity to that of the magnet. But the point which is near to the magnet and inducing a magnetism in itself, the polarity is totally different from that of the permanent magnet. Induced magnetism is temporary process. If the permanent magnet is removed, the magnetic material will usually loses induced magnetism. So here it is a very important line written here that the permanent magnet induced magnetism is a temporary process. Means if you remove the magnet from that material, the magnetism property in that material is removed. That's why it is written here, induced magnetism is a temporary process. If the permanent magnet is removed, the magnetic material will usually lose its induced magnetism. Then it will loses its magnetism property. Now we will move to stroking method, or you can say it is single touch method. Now what happened in this method? We just look here. Take a soft iron piece which is to be magnetized. We take suppose we take an iron piece in which we have to be create magnetism, and place it on a table. You can see this process in figure 6.13 here. It is written figure 6.13. I hope it is not given there. Okay, no issue. So take a soft iron piece which is to be magnetized and place it on a table. Rub the soft iron piece with any one end of a bar magnet, say north pole, along the length of the iron piece. Repeat this step many times without changing the pole and direction of rubbing. The soft iron gets magnetized into a magnet, and the soft iron types what happen? Changes into the magnet. Now we will come to types of magnet. Here there are types. We will study about the types of magnets. So on the basis of how long magnets hold their magnetism, they are classified into categories. On the basis of magnetism means how at up to how much time a magnet will hold its property of magnetism in it. On the basis of this, we will classify a magnet into two categories. One is temporary magnet and the other one is permanent magnet. So first we will study about the temporary magnet. So these magnets hold their magnetic property only for a short period of time. Means for a very short time These such type of magnets hold the property of magnetism. Such magnets are usually made of iron, nickel or cobalt. Temporary magnets behave as a magnet under the influence of strong magnet, and as soon as the strong magnet is removed, they lose their magnetism. Just take the example of, as I already told you, any magnetic material like iron placed on a permanent magnet near on a permanent magnet, and it acquire a property of magnetism. So temporary magnet behave as a magnet under the influence of strong magnet. Fine. Magnet prepared by single touch method, double touch method and electrical method are temporary method. This is the line written here. You have to study materials which are prepared by the double touch method, single touch method and electrical method are temporary magnet. One such example of magnet is electromagnet. As we had study in the previous classes, that the electromagnet is a temporary magnet in which if we stop flowing current through the circuit, its magnetism property is removed. Now we will come to permanent magnet. So what is the permanent magnet? Here you have to study. The magnetism of such magnet lasts for a long time. Those magnets whose magnetism is acquiring property for a long time are known as permanent magnet. They do not lose their magnetism. Means if you remove the magnet, they do not lose their magnetic property. They hold the property of magnetism in itself. Naturally occurring magnets are permanent magnet, but they are usually weak magnets. The magnets which occur naturally in the nature are known as permanent magnets. Strong permanent magnets are made artificially by various industry purposes such as to lift very heavy loads, magnetotherapy, etc. They are made using iron with aluminum, nickel and cobalt. Steel is also used in making such type of magnets. So these are the examples. So that's all for the today's class, students. Thank you.